Good morning, students. This is the new video. It is on iron carbide diagram and structure. This is the phase diagram of iron and iron carbide diagram. On x-axis we have temperature in degree Celsius and have the composition, that is the percentage of the carbon. Up to the 2%, 2.3% we have a steel, and above 2.3% to 6.6% we have a cast iron, and we have different phases in this diagram. So iron carbon diagram, it had iron, steel, cast iron. The iron are alloy with less than 0.008% by weight of carbon. The steel are the carbon iron alloy with carbon in a range of 0.008% by weight to 2.14%, and the cast iron contain 2.14 to 6.7% of carbon. Iron and carbon combine to form Fe-Fe3c at 6.67% of the carbon, that is the end of the carbon, and eutectoid 0.76 per by weight of carbon to 727 degrees Celsius. Then austenite, that is the gamma, is formed two different type of solids in eutectoid reaction. You can find here where we will get the different type of the reaction. This is the eutectic reaction we have here. Then eutectoid reaction is here. Then we can find out this is the steel, this is the cast iron zone, then this is the ferrite and cementite, and then pearlite and carbide. These are the structure we will get after cooling the liquid. The various phases that appear on iron carbon equilibrium phase diagram are as under: austenite, ferrite, pearlite, cementite, martensite, and ledipurite. The unit cell of various metal, you can find this is the FCC structure for austenite, this is the BCC structure for ferrite, and again we have a martensite. So the unit cell for austenite, ferrite, and martensite, the effect of the percent of the carbon by weight on the lattice dimension of martensite as shown in figure D. Note the interstitial solution of the carbon atom and increase the dimensions of carbon with increase the carbon content. Thus, unit cell of martensite is in a shape of a rectangular prism. This is the, we can find out, this is the rectangular prism. And this happened due to, this is called the sum of the interstitial atom. We have the carbon atom are placed inside this ferrous atom in an interstitial space. The ferrite is known as alpha solid. It is interstitial solid solution of a small amount of the carbon dissolved in BCC iron. You can find out in the previous slide that this is the ferrite. Okay, and this ferrite have BCC. BCC means body centered cubic. We have the ferrous atom at the center and 8 atoms at 8 corners, and which have the weightage of 1/8 of its volume. The stable form of the iron below 912 degrees Celsius. The maximum solubility is 0.025% of the carbon at 723 degrees Celsius, and it dissolves only 0.008% of the carbon at room temperature. Hence, this ferrite is known as the alpha side, and it have the lesser solubility of the carbon. It is the softest structure that appear on diagram. This is, we can find out this is the structure of ferrite, and it have the certain properties. It have the tensile strength of 40,000 psi. Elongation is 40% in 2 inch, and hardness is near about Rockwell number B, that is 90. The pearlite is another type of the structure, is a eutectite mixture containing 0.8% of the carbon, and it is formed at 723 degrees Celsius on very slow cooling. It is a very fine plate-like or laminar mixture of the ferrite and cementite. The white ferrite background or the matrix contain the thin plates of cementite. So you can find out this is the ferrite and these are the cementite. So this is, we can say, it is a laminar structure of both, that is called the ferrite and cementite. The pearlite have some properties. It have the tensile strength of 1,20,000 psi, elongation of 20% in 2 inch, hardness, Rockwell hardness, that is the C square is 20, Rockwell B is 95 to 100, and Brinell hardness number near about 250 to 300. Austenite is an interstitial solid solution of the carbon dissolved in gamma FCC iron. The maximum solubility is 2% of the carbon at 1130 degrees Celsius. The high formability, most of the heat treatments begin with this single phase. It is normally not stable at room temperature, but under the certain condition, it is possible to obtain the austenite at room temperature. The austenite have the following properties. It have 1,50,000 psi tensile strength, 10% elongation in 2 inch, hardness value Rockwell C is 40, and it have the high toughness value. Cementite or iron carbide is very hard, brittle, intermetallic compound of iron and carbon, as Fe-3c contains 6.67% of the carbon. It is hardest structure that appears on a diagram. Exact melting point unknown. Its crystal structure is orthorhombic. It has low tensile strength and high compressive strength.